Morning, everybody. Welcome to the introductory talk on AR over the web browser using ARjs, ARFrame, and WebXR. My name is Don Shin, and I'm the founder and CEO of a web, mobile, and immersive app development studio named CrossComm, located in nearby Durham, North Carolina. And I've been doing this thing for a little more than 20 plus years, and so obviously I haven't been doing all of that for the entire time. CrossComm actually started off as a web app development studio. And having done this for quite some time, I've seen a lot of different transformational shifts over the years. And one of the most memorable was when Steve Jobs introduced the iPhone and said, you can develop apps for the iPhone. They just have to be web apps running in Safari. It's a true story, but there actually wasn't any native apps when the original iPhone launched. And we, being a web app development studio, said, well, we can do that. We build web apps, so let's build one for this upcoming iPhone. We built a very, very simple memory-based game called Lumina, similar to Simon, made it run all with JavaScript. It ran through the web browser using some screenshots of the iPhone on Apple's website and some reverse engineering of their HTML. And the iPhone launched. We all waited in line to buy the original iPhone, ran our app, and it sucked. Well, actually, it was okay, but it sucked in comparison to Apple's native apps. Apple's native apps ran silky smooth. They were responsive. They were performant. They felt like really polished experiences, whereas ours, being a web app running through Safari, every time you tapped on a button for this memory game, you had like a quarter of a second delay before the image changed, and it just felt like a less than an iPhone experience. Well, over time, people really lobbied hard to build native apps for the iPhone, and our effort in building Lumina was not all lost, because it did get Apple's attention. They graciously gave us access to a beta of the iPhone SDK, and we were able to port Lumina to become a native app, and it was awesome. It was responsive, it was fast, it had musical sounds, whereas the web version, the sound didn't work. And so that allowed us to transition and become not just a web app development studio, but a web and mobile app development studio. So having shared that story with you all, you're probably wondering, why am I up here talking about web-based AR? Well, an interesting thing happened over the next 10 years. We saw web apps get faster. We saw JavaScript interpreters become JIT compilers, just-in-time compilers. We saw hardware get faster. And then we also saw increasing access to the hardware's native capabilities, sensors like the camera, the microphone, the GPS radio, support for musical sounds. And web apps started to suck less. And in fact, the use cases for using a natively compiled app became fewer and far in between, because even if web apps didn't perform as well, they performed well enough. And I believe we're already starting to see that same kind of shift, that same kind of dynamic of seeing capabilities with augmented reality come to the web browser, and we'll soon hit a point where the experiences can meet a broad variety of use cases. And I'm really looking forward to and super excited to share why I'm so excited about augmented reality through a web browser, and why I believe web is the future of delivery for rich, immersive XR experiences. Before we dive in too deep, I just want to make sure we're all operating off of the same terminology, starting with virtual reality. Virtual reality experiences put a user in another world, another reality, and that's what we see here with this clip. We see a player of a very popular VR game called Beat Saber, and clearly the player is not in her present reality. She's in a computer-generated one. Virtual reality experiences for the consumer started off as 3 degrees of freedom experiences, or 3 DOF experiences, meaning they honored the change of perspective based upon the rotation of the user. So someone, perhaps maybe you all had your first VR experience with Google Cardboard, or maybe an Oculus Go headset, and you could rotate your head around to see the world around you, but you couldn't move around, or maybe if you tried to move around, you could move around physically, but the virtual reality experience would not honor that movement. Very soon, 6 degrees of freedom, or 6 DOF experiences, became accessible to the consumer through things like the Oculus Quest headset, as well as AR frameworks like ARKit for iOS or AR Core for Android. And they allowed the user to experience not just rotation of their perspective, but also positional change of movement as well. That leads us to augmented reality. Versus virtual reality, augmented reality serves to modify or augment the user's perspective of their current reality, not transport someone to a different place, or rather to enhance or to augment one's experience of their reality. And here we see a clip of a demo that we created with this model of a motorcycle, and you can see the motorcycle is real, but through augmented reality, we're able to see overlays, informational overlays around the motorcycle. We're able to change the perception of the motorcycle by changing its color, or even having some mixed reality effects and valuing of depth, and have imagery dash and dart in front of and behind of the motorcycle. A lot of fun things you could do with augmented reality. And the best part about augmented reality is that it keeps the user rooted in their reality so that they can still use augmented reality alongside their work, alongside their play. Augmented reality is almost always a 6 DOF experience, meaning that the imagery and the output that the computer is giving you values not just the rotation of your perspective, but also the positional change of your perspective as well. Simple AR applications that you may have run into would be using AR with markers as anchors. A marker is basically some kind of visual symbol picked up by the camera, and that visual symbol is used as a spatial anchor or reference point by which the app knows where and how to place the computer-generated content. And so, so here, this is a medical app that we built for the HoloLens that uses AR markers. You can see those codes there on the paper serve as spatial anchor points for the 3D content. We're also starting to see the emergence of markerless AR experiences, i.e., augmented reality that doesn't need some kind of visual marker, but through an understanding of the world around it, it can start to map out the environment, perhaps recognize horizontal surfaces. Right now, I'm showing you a fun little parlor trick that we developed, and you might have seen on Twitter, of creating a portal on an arbitrary horizontal surface, no image marker necessary. And this is accomplished using simultaneous localization and mapping technology, or SLAM tracking for short. This particular demo is utilizing iOS's ARKit SLAM tracking. And with that tracking, the user is able to hold the phone and walk into the portal, turn around, walk out back into the real world, or just continue looking around in that fictitious virtual environment. That's all done through ARKit's SLAM tracking. So far I've been talking a lot about some cool things that you can do with compiled app technologies like ARKit and the HoloLens, but let's talk about web-based AR and why it's so appealing. Some of these answers are super obvious. Firstly, no app install. I cannot overemphasize how much of a friction point it is to ask our users to go to the App Store and to download an app especially for a spontaneous experience. It's so much easier to provide a link, a hyperlink, or even a QR code that points to a web-based experience. We even started using QR codes on some of our flyers, which is what the video example is showing right now, to direct users to web-based content. Also, you've probably seen the news, the whole, should we say it, quarrel, intense conversation about App Store fees and about distribution through the App Store. And not having to distribute your app experience through an App Store means two things. Firstly, you can better monetize your app if you so wish without having to go through a mediator like the App Store. And also, no store review waits. I can't tell you how many times we, as an app developer, have tried to help our clients publish an app only to go through an excruciating process of waiting for the app to be reviewed and then to be disappointed to find out that the app was rejected and start the submission process all over again. With web deployment, it's instantaneous. And if you want to make a tweak, the deployment is instantaneous as well. The web is inherently cross-platform. That's what the web was designed to do, was to serve as lingua franca based upon established open standards and deliver similar or identical experiences across a number of platforms. It's a big weight upon a developer's shoulders to have to support multiple platforms and multiple implementations. And if we can develop for the web, that's going to lessen the effort for deployment and just make our app more easily accessible across the board. One interesting tidbit about that Lumina story that I shared earlier is that we've got about, I think, 20,000 people downloading the native Lumina app on day one of the iTunes App Store, which was a modest success given that there were only 500 native apps at the time. But I think we had over 100,000 visitors and users of the web-based version of Lumina, because even people who didn't have an iPhone were going to the website through their desktop browsers and playing the memory game. And so that just goes to show how wonderfully accessible web content is. Finally, I want to reference what I call the Web 2.0 effect. With web applications becoming standards-based, you're starting to see web applications assembled from parts of other web applications and other services and APIs. And you can actually now create a tremendous amount of value by integrating a lot of different functionality and data sources and APIs and services from different places to create your own web app. That's led to an explosion of creativity, a renaissance of innovation over the web. And it's something that I'm very much looking forward to happen to the AR and the XR ecosystem as web-based AR becomes more prominent. So those are all great reasons. Why hasn't web-based AR taken off yet? Why hasn't it taken over already? Well, there's been some significant historical challenges that have prevented web AR from really succeeding. Firstly, standards-based access to sensory hardware. AR is dependent on understanding the world around you. If you cut off that access, AR cannot do its job of augmenting your reality. And so AR intrinsically and inherently needs to have access to sensors, the camera being a main one, but also AR could be audio-driven and microphone-driven. It could be driven by other sensors like LiDAR or infrared or other custom controllers. Augmented reality relies upon having an awareness of the world around you. And web apps have historically been within a sandbox. Of course, we've seen some evolution, and I'll go more into that, but that's been a historical challenge. I referenced the idea of performance and responsiveness earlier. How Lumina performed so much better as a native app. How it was responsive and felt like it just felt like a tight, awesome experience. You know, with augmented reality, a lot of the processing of what comes into the camera is done by computer vision, and that's very CPU and sometimes GPU intensive. That's very processor intensive. And so performance has definitely been a consideration. Mature building blocks and frameworks and middleware for compiled AR apps. The AR ecosystem has been around for a while, and there are already mature frameworks and tools that you can leverage to build a quality AR app experience if we're willing to go the compiled route. One very popular AR library vendor is Vuforia, and their library, their framework works rock solid in terms of recognizing trackers and other capabilities. There are pre-existing game engines and development environments like the Unreal Engine and Unity that drive a lot of our interactive experiences in entertainment today. And finally, there are libraries that are provided by the underlying operating system itself. ARKit, provided by Apple in iOS, and AR Core, provided by Google in Android. So you could do a lot and do a lot of quality work if you go the compiled route. That all kind of sums up into this idea that it's just sometimes easier to develop compiled apps. It's better, easier development environments. This is a screenshot of the Unity development environment. One of the things about immersive media is that it's all existing in a 3D space. So it becomes one dimension more difficult to lay out your scene, to construct your immersive VR or AR or spatial experience if you don't have similar graphical tools to help you do that. This is a diagram of the typical compiled AR ecosystem today. What we've got is we've got the hardware, a low power CPU. I say low power because most augmented reality experiences run on portable devices, and portable devices are always concerned about being conservative with power consumption. Some kind of GPU and then an array of sensors like the camera or the microphone, or in some cases a LiDAR sensor. You've got the operating system, which can possibly include frameworks that help you with AR capabilities like ARKit and AR Core. Oftentimes, you've got a game engine or dev tools or middleware assisting you with out-of-the-box functionality to create great experiences, and then you've got your code as a developer compiled to run on this entire stack. And the beautiful thing about all this is that your code oftentimes have great access to all of these levels below it, whether it be libraries like ARKit and AR Core, or access to the sensors, or a lot of experience functionality provided by the game engine. When we first developed Lumina for the original iPhone, this is what the web-based ecosystem looked like. You had your low-power CPU, you had your OS, and then you had a web browser running on top of the OS and a browser sandbox where interpreted JavaScript and HTML was isolated and protected for security reasons, but also it prohibited you from creating any interesting or fun or unique app experiences. So yeah, web apps at the time kind of sucked. But something again happened. Something changed over the years. Started to see interesting emerging standards start getting adopted, like WebGL, which gave web apps access to OpenGL and access to the GPU power for 3D graphics. We had device APIs like WebXR that standardized the protocol and communication between web apps and other sensors that are common in AR and VR experiences. We started seeing the performance of web apps improve significantly so that JavaScript was no longer just interpreted, just-in-time compilers and JavaScript engines like V8, as well as innovations like WebAssembly allowed for the performance of web apps to fall just shy of native apps. And it didn't hurt that mobile phones pretty much multiplied in power in a very short period of time. And then finally, in terms of out-of-the-box functionality, we started to see frameworks like Three.js and ARFrame emerge so that you could build quality experiences using immersive technology, immersive content with very little effort. Going into those two in particular, Three.js has been around for a while. It's a JavaScript-based 3D library that allows you to write JavaScript code to instantiate 3D graphics and objects. Pretty darn cool stuff by itself. It's all accelerated by the GPU, so it feels very similar to a native app. And then you've got ARFrame running on top of Three.js. ARFrame is an entity component system. Entity component systems are data-oriented architectural systems that lend themselves well to game development, because basically, instead of object-oriented objects that derive their identity from a class or a subclass they inherit from, entities derive their identity by their association with named sets of data, i.e. components, and you can mutate those components, assign those components to other entities on the fly, and those entities start to adopt the behavior that comes from those data sets through the systems that process those components. I know that's a lot. I would strongly suggest that you look into entity component systems on Wikipedia if you want to develop game-like experiences. But the awesome thing is you don't have to use a development environment like Unity to take advantage of entity component systems. You now have ARFrame optimized for creating VR and immersive experiences, providing an entity component system and allowing you to instantiate objects and UI through declarative HTML. Pretty cool stuff. Here's an example of an entity supported by ARFrame, where this entity in particular has a unique ID, and then it has components, i.e. named sets of data like geometry, material, position, light. And by assigning those sets of data to this entity, the systems look for those components and start to operate and provide functionality to those entities. We'll get into that a little bit more in the hands-on code exercise. And then finally, here's what's also interesting. Three.js has a free editor, and ARFrame has a visual inspector. And granted, I'm not saying that it's just as easy to develop on ARFrame and Three.js as it is on Unity, but at least not yet. What we're seeing is the emergence of a better ecosystem to craft 3D environments through web-based technologies. So what is ARjs, and where does that play in? ARjs is a JavaScript framework. It's an abstraction of another technology, JS AR Toolkit 5, which also stems from AR Toolkit 5, another open source project. And the thing to know about ARjs is it gives you 3 features out of the box. Image tracking, using natural feature tracking, so it can recognize a photo if you can train it to recognize that photo. Gives you location-based AR, a kit to develop your own GPS-driven location experience. And then it also gives you some simple pattern recognition or marker recognition for recognizing lots of patterns or QR codes within a single AR experience. You can use ARjs on top of ARFrame, or you could use it just on Three.js alone. So probably what's most interesting to devs is to see code and to see just how easy it is to start dealing and entering into the world of 3D objects. So let me exit out of Keynote here. Okay, so step number 1. When developing for new technologies, if you're not familiar with 3D graphics at all, I would really recommend you take things one step at a time. And so even if you have a vision of creating this AR opus, take it one step at a time, and we're going to do that right now. We're going to try to get a 3D object to display in a web browser. So here is the simplest web page ever. I've got a body, and inside the body, I've got an ARFrame HTML tag, a scene. And inside my scene, I've got an entity, very similar to the one that I had in the previous slide. This entity has a component, data for geometry, being a box primitive, has some material specs, some position specs, and some rotation specs. So we're going to preview it right now. Oops. Hey, look at that. It's a box. It's a performant box. It uses the GPU to render, so it's not just some software rendered thing. If you like experimenting with HTML, you could do all sorts of fun stuff. You can start copying and pasting and creating more entities. Let's make this one a sphere. We'll make this one this one 9999 FF. If I got my hexadecimal right, there should be a blue, green, and red object. And they all have the same position along XYZ coordinates. So I'm going to change that up. I'm going to make this one a little bit taller. And I'm going to make this one to the right. Save. Hey, look at that. So you can see, just with simple declarative HTML, I can start to generate my 3D scene and create what I want the user to experience. So you're all probably saying, this is great, but I would never want to use primitives in my work. I want to actually see real artwork and the stuff that I'm used to seeing. So the cool thing about ARFrame, it has great support for rendering GLTF, GL transmission format objects, which are a bundle of files describe a 3D object or a 3D scene. Sometimes you might also find GLTF format content bundled all into one file, a GL binary or GLB. And what's really, really cool is that Sketchfab has a ton of pre-existing artwork under the Creative Commons license. And looking at this one, I think this one's really interesting for me. Sort of has the beginning of a story that I would like to tell. So let's try to download it. And I can see, look at that, GLTF and GLB are both available. Because I don't want to leave anything to chance, I've already downloaded this model and I've already included it in my Visual Studio Code project. So let's close up this window here, but I wanted to show you just how easy it is to experiment with pre-existing content. So step 2 is getting past primitives. Look at that. It's as simple as referencing the path to the GLTF model. And let's see how that works out for us. There it is. In fact, I'm going to show you. Not Randy's pizza. See that? This is a screen share of my iPhone. ARFrame, being a web VR framework, gives you a lot of cool out-of-the-box functionality. For instance, you've got a VR display mode here. And I've lost the model. But you get the picture. Basically, it has support for Google Cardboard as well as other VR devices. So we've taken it one step further. We're now no longer dealing with primitives. We're now dealing with model objects, and it was super, super simple, which is what I like. But you didn't come here to create a VR experience. You came here to learn about web-based AR. And again, this is where ARjs comes in. So in this iteration of the code here, you see that I've now included ARFrame-AR.js, which is the ARjs library that is compatible or sits on top of ARFrame. I've included that. Added some additional parameters like turning off that VR button because we're not interested in VR. Some other preferences and parameters specific to ARjs. And you saw my entity from the last step, but I've now wrapped up this entity in an A marker. This A marker is a marker that's going to be recognized in order to trigger AR. And once that marker is found, the content that's nested hierarchically is going to display. One note about this marker, I am using a preset that's built into ARjs, the hero marker. And I'm doing that because I don't want to leave anything to chance. So let's see how that works out. There we go. Super simple, super easy, sort of. So we've now got a model sitting on top of the recognized image marker. So I mentioned that there's a lot of benefits and advantages to the entity component system. And that is that all those components, those named sets of data, you could tweak them. You could tweak them in the code. You can mutate them on the fly through JavaScript. And you could start to change attributes and start to create interactivity through handling events and then mutating and changing those named sets of data. And it also allows for a lot of reusability as well. So what's really cool, let's move to the last step here. I've added libraries to handle new kinds of components, an animation component, a particle system component, and I could start to add that component data to my entities. So here, the biggest difference is this line right here: animation, property rotation, easing, linear duration, 60 seconds. The goal is to rotate it 360 degrees along the y-axis, and I want it to loop. And I've also added a new entity nested in this hierarchy. Particle system equals preset snow, velocity value 020, particle count 10,000. I didn't create this particle system. That comes courtesy of the team at Idea Space VR. But you could see now how this Web 2.0 effect of just explosive creativity and innovation can happen when you could start to use components created by the community and then add those components to your existing entities. So let's preview this now. You see on the projector, you see little bits of snow. And the music box is slightly rotating in the opposite direction. So now I'm starting to tell a story of this placid, intimate experience of friends quietly observing the snow falling around them. But I want to experiment. I want to tweak. So let's do that. I happen to have played around with some of the settings beforehand. So I'm going to comment that out and comment this in. And this ups the particle count to 30,000. And it also adds an animation component. I'm making the blizzard rotate. And then let me save, reload. And show you guys. Whoa, look at that. Completely different narrative, completely different story. Instead of a peaceful, calm scene, I see two friends desperately seeking comfort in each other, but they're unable to do so because they're inanimate objects fixed to a music box in the midst of a blizzard. So the great thing about that is that just the tweakability and the changeability of this data allows you to craft the kind of experience you want, and it's super, super easy with the entity component system. Make sense so far? Cool. So yeah, that's our little code exercise. And if you look, really, it's this much code. With the help of some great libraries and components, we're able to create that kind of experience. Cool? Feeling encouraged, feeling emboldened to try something out yourselves later? Very cool stuff. So getting back to the presentation. So that was easy, and it was not, because there was a lot of work that is not represented in that code. Firstly, I didn't just show you the iPhone screen. I didn't just show you the iPhone screen to show you that it works on an iPhone. Some practical tips for developing your own experiences that will save you some time. You should work on setting up a local HTTPS server for dev. And the reason why is because although you could do some debugging of AR through your laptop's webcam, if you try to get the app running on an external device that's not localhost, the browser will require HTTPS in order to allow for WebRTC, or in other words, access to the camera. So in order to actually do dev in this environment and to test out my web app on my phone, I had to set up an HTTPS server for previewing my stuff. And I'll share some links at the end of this presentation on how to get that set up fairly quickly, because if you're doing dev, oftentimes it's because you didn't want to do DevOps. Also, when you're dealing with a new technology, or when you're dealing with beta technology, and in some cases this feels like both, again, iterate one variable at a time and develop incrementally. There is a reason why I iterated through those steps, because I wanted to show you that if you just build upon the previous step, get something working, change one variable, get it working, you can then make decent progress. The first time I tried creating an ARjs and an ARFrame app, I had this grand vision in my mind. I started doing custom patterns, custom scenes, and then I tried loading it up and nothing showed up. And then I had to troubleshoot a whole bunch of bazillion different things that can go wrong. And there's a ton of things that could possibly go wrong when trying to do web-based AR. So increment and iterate one variable at a time. Also notice that in immersive, content is still king. If you look at that experience, for those of you who are familiar with compiled augmented reality apps, the tracking is not great. The AR is not great. But if you have quality content, that actually takes the attention and focus away from the technology and more on the story or the message you're trying to tell. And so here, for perhaps maybe my trained eye that's looking at the technology, I'm like, oh, this tracking is horrible. For my daughter, she's like, oh, cool, Blizzard. And so content is still king. If you're not an artist or a designer, a visual designer, partner with creatives and artists for the assets so that you don't have to just resort to primitives. And then finally, when developing for ARjs, leverage WebAR's unique strengths that native apps cannot. One example of that would be you could create a QR code that goes to your web-based experience and doubles as a marker. And that way, the app, that's a level of spontaneity in experiencing your AR content that is unparalleled, that a native app, even if it performs better, cannot match. And then if you're working with a stakeholder or a product owner, manage expectations around the shortcomings. Obviously, this is not SLAM tracking, so don't represent it as SLAM tracking. It's marker-based AR, and the markers have some limitations in terms of having to have unique features in those images. So just manage expectations that what you're giving up in flexibility and performance, you're gaining in accessibility with web-based AR. Real quick, what does the future hold for web-based AR? Because what we saw was cool, but there's so much more that we can do, and there's so much more we will be able to do. Firstly, the biggest revolution, in my opinion, by far, for augmented reality as a whole, is when we transition from handheld AR to hands-free AR. It's the form of wearables. You know, the most frequent and helpful device as a parent when I'm grabbing my kids or when I'm at the grocery store hauling groceries is not my iPhone. It's actually my Apple Watch, because I don't need a hand to use it. Similarly, there are so many applications waiting to be invented and waiting to be utilized in enterprises, workplaces, and entertainment venues, but are only possible if you don't have to use one of your hands to do so. So many applications within manufacturing centers, factories, warehouses, hospitals, that require you to have two hands free and available at all times for efficiency as well as safety reasons. Augmented reality will help with all those possible contexts once it becomes hands-free. Here's an example of hands-free AR with the Microsoft HoloLens 2. And of course, smart glasses are right around the corner someday. The web browser, like the mobile app, the web browser will address an increasing number of AR use cases, especially as standards like WebXR and also OpenXR start to get universally supported by operating system vendors, device manufacturers, and web browser developers. And it's going to start to allow web developers to access all of that rich functionality and sensor goodness. All that stuff that's provided by ARjs, like market tracking and SLAM tracking, I predict those will become standard features the OS will provide and expose to web browsers, native apps, and web apps. We're already starting to see that with ARKit and ARCore, and there's no doubt in my mind that that's just going to become a de facto feature and option as operating systems become more AR savvy in the future. And finally, even though what I showed you are open source technologies with ARjs, AFrame, and WebXR, we're going to also see commercial entities get on the bandwagon and provide support for web-based AR solutions and frameworks as well. That's the future, but what should I do today if I want to get started creating AR experiences for the web now? Well, first answer to that, as my computer science professor in undergrad would say, is that the answer is always it depends. Depends what the priority of your project is. If you are looking for performance above all else, the native compiled route is still the way to go. And there are many libraries that provide AR functionality, not just ARKit and ARCore, but also commercial frameworks like Vuforia and Wikitude that provide great image marker, 3D object recognition, SLAM tracking functionality, you name it, for a price. But if what you need is performance and reliability, then optimize for that. If accessibility is priority, then look into what's available for the web, which pretty much is ARjs, but there's also a couple of other options. Google has provided access to the ARCore functionality through its Chrome web browser. Unfortunately, Apple has not yet done the same for ARKit through Safari for iOS. But if web-based options are priority, there's also Eighth Wall, which provides SLAM tracking through a web browser. If you're looking for free, then you've got ARjs and AR Toolkit X. If you're looking for open source, those same two options are available. And that's a completely fair question, given that this is an open source conference. Depending on what kind of features you need, whether you need SLAM tracking or image marker tracking, there's a multitude of possibilities, and you just kind of have to optimize for the right one. So although I believe web-based AR is the future of delivery of rich XR experiences, I also think that in the meantime, we have to be practical and choose the best option for your project's needs. That's pretty much all the material I have to share with you today. I've also listed some resources and URLs that will help you on your journey if you want to experiment with web-based AR. There's the links to the frameworks, and there's also some links that will be helpful if you want to set up your own HTTPS server. But more than anything, I really hope that you all are excited to see the potential of not having to download an app, but to have immersive experiences, especially, and I really actually mean this in sincerity, the smart glass is right around the corner. We're going to start to see the same kind of explosion of apps and utilities that we saw with the emergence of the smartphone. But we're going to see that with wearables. And they're going to be a part of every aspect of our lives, especially because they're hands-free. And so I think it really is advantageous for us to get familiar with creating three-dimensional immersive experiences today with the technology and tools we have, so that we're ready to take advantage of that paradigm shift. I've seen a lot of different paradigm shifts in my career, and this upcoming one is the most exciting by far. Thank you all for your time and attention. Hope this was useful, and again, hope this got you excited about web-based AR. Any questions? We have a little bit of time. Great question. So ARFrame, so the question was, what is the relationship between native JS events? And the thing about ARFrame is that it creates its own three-dimensional rendering canvas. And so it deals in the realm of synthetic events. You can bridge the events together so that your standard JS events interact with ARFrame content and vice versa, but you'll have to write that code, that bridging code to do so. Yeah, so the wonderful thing about ARFrame that is also a key advantage over these compiled apps is that it's all DOM. It's all document object model stuff. It's so you could add your own custom data. You could add your own tags. It could be parsed and machine read by other systems. And you could even create a component that handles a certain type of named set of data for accessibility purposes. So I think ARFrame experiences have so much more potential to be accessible experiences that maintain as much fidelity as possible. Obviously, some fidelity of the experience will be lost if you are sight impaired or if you are immobile, but it allows at least for, I think, as much integrity of the experience to be retained as possible if you're trying to serve an accessibility centric audience.